Morning folks, welcome to the Proving Trig Identities lesson. It's a difficult topic to teach. Students find this a little bit difficult, but there are certain structures, rules and thought patterns that are repeated over and over again in these types of questions, whether it's the pure 1 or pure 2. So without further ado, let's crack on, get the job done. Here's an example, and always bear in mind what you're aiming for. Look at the right hand side and think, right, that's got to shape my thinking in what my steps should be. Thought. The right hand side's got cos squared in it, the left hand side's got tan squared in it, so let's convert the tan squared. And therefore the left hand side, tan squared plus 1 becomes sine squared over cos squared plus 1. And then compare that to the right hand side, and the right hand side has a single fraction in it. So what I've got, sine squared over cos squared plus 1, this here, I need to put this all together to form a single fraction because it's got to look like this right hand side. So 1 becomes cos squared over cos squared, and then when I add those together I get that, and therefore that gives me the final answer. Now note, by the way, up here, folks, note up here, this is tan squared plus 1 equals sec squared. That's one of our identities anyway, okay? I'm just using this as an example to show you some thought processes, okay? And we're going to use those and repeat those in our next two examples. Here's example 2. Always look at the right hand side, or the side that you're aiming for. I'm going to go to aim for the right hand side. Look at the structure of that answer. It's a single fraction, it's got cos squareds in it. That should shape our thinking. So the left hand side's got a tan squared in it, the right hand side's got a cos squared in it. Let's change that tan squared into sine squared over cos squared. So now my left hand side looks like that. I then look at what I've got compared to what I'm aiming for up here. And as I said, what I'm aiming for up here is a single fraction. So I need to turn what I have here into a single fraction. Here's a new thought in a different colour. The numerator is in the form of a difference of two squares. That's sine squared squared subtract cos squared squared. It's a difference of two squares, so we can factorize it. A sine squared plus cos squared, sine squared minus cos squared. And note at the same time here, I've replaced sine squared with 1 minus cos squared. Now this denominator here is the same as the denominator up there. So this numerator must be the same as this numerator up here. Well, if I have a look at this numerator, it looks a bit of a mess, but that first bracket is just 1, so that disappears. And then in the second bracket, all you need to do is swap sine squared for 1 minus cos squared, and that'll give you that numerator, and we're done. Here's example 3. Now, you might, when you look at example 3, think the following. If I could just cross multiply, I'd be pretty much done. If I cross multiplied, I'd end up with sine squared up here, and I'd end up with 1 minus cos times 1 plus cos, and that'd give me 1 minus cos squared. But you can't cross multiply, okay? You can't do that. All right. Yeah, it gets you there to something which you think is right, but you can't do it. However, it does give you a way of realizing how to do it. In fact, it will give you 2 ways. Let's have a look what I'm talking about. Cross multiplying would involve multiplying the right hand side by sine theta. Now you can't just multiply the right hand side by sine theta because that just completely changes the value of the right hand side. However, you can multiply the right hand side by sine theta over sine theta because sine theta divided by sine theta is 1, and multiplying anything by 1 doesn't change its value. Therefore, if we multiply the right hand side by that fraction, we end up with that. And now sine squared can be rewritten as 1 minus cos squared, and 1 minus cos squared is the difference of two squares. It's 1 minus cos times 1 plus cos. And now if we look at our numerator, we can see that 1 plus cos and 1 plus cos, they're going to cancel out. And what are we left with? 1 minus cos over sine, which up here is our left hand side. Okay, so initially if we'd have thought, oh, if only we could just multiply by sine theta, well, you can multiply by sine theta over sine theta. So redoing example 3 in a different way, cross multiplying would involve multiplying the left hand side by 1 plus cos theta. Well, we can't just multiply the left hand side by 1 plus cos theta because that changes its value, but we can multiply the left hand side by 1 plus cos theta over 1 plus cos theta because that's just multiplying it by 1. And when we do multiply it by that, lo and behold, 1 minus cos times 1 plus cos becomes 1 minus cos squared, and we've got 1 plus cos theta over sine theta in the denominator. But 1 minus cos squared is sine squared, so now our sine squared in the numerator and sine theta in the denominator, those bits cancel out, and we're left with sine theta over 1. So, to recap, you can only work on one side of the identity, can't swap between the two. If one side has got tan in it and the other's got sine or cos, then swap out your tan for sine cos. Similarly, if it's got sec in it or cosec in it, but the other side's got sine or cos, try and turn the identity so it's got the same trig function in it, okay? If you've got two terms together, but what you're aiming for is a single fraction, try to put the two terms together. The opposite of that is also true. If you have a single fraction, but the other side has got separate terms, you might be able to separate the numerator of your single fraction to make two fractions. Look out for the difference of two squares. It does come up relatively frequently, and make sure you know those trig identities thoroughly, as it makes it so much easier to spot the method for proving the identity. Now, here's a worksheet of questions, and there's also in Pure 2 3 questions that you need to go at too. I'm just going to talk you through this exercise here in general terms. Question number 1, I've got a single fraction on the right hand side, so I want to put these together as a single fraction on the left hand side, and I've also got sine squared on the right hand side, so I want to swap that tan squared out. Okay, put that tan squared in terms of sine squared and cos squared. Similarly here, question number 2, my right hand side's only got cos in it, so I want to swap that tan for sine over cos, and then I want to bring those two terms together as a single fraction. In question 3, my right hand side has got two separate terms, my left hand side's got a single fraction, so I want to separate this numerator. I actually want to break this fraction up because I want two separate terms. In question number 4, I think 1 minus sine squared has got to become cos squared there. In question 5, same thing, tan has got to become sine over cos, and I've got to bring these two terms together to make the single fraction. Question 6, again, get rid of tan squared and also put all that together because it's got to equal that single fraction. In question number 7, I'll probably go from right hand side to left hand side. I'll probably swap tan out for sine over cos. That'll bring the cos up here to make cos squared, and I'd rewrite cos squared in terms of 1 minus sine squared, and it'll separate out into the left hand side. And question 8, I would just multiply that out, okay, those two brackets, and I'm going to have a tan squared there once I've done that, and I'd put that tan squared in terms of sine squared over cos squared, because it's got to, if you like, put together with this term here, which will be 1 over cos squared. Okay. So pretty much as I walk through that exercise, it's the same kind of thing, isn't it? Okay, swapping out tan, bringing terms together to make a single fraction, and spotting identities. Okay, folks, good luck with that exercise, and then just get more practice with these questions here, because really the more practice you get, the more proficient you become. Best wishes, folks. See you later.